Okay, let's just start week 7. We have 13, I think 13 people at the moment, but as usual, a couple more people will join in during this session, I think, and hopefully. And we started with 30 people, and now we have about half of them. It's pretty sad, but I will do my best to have more people in the next session. So next semester. Before we start this semester, I want to tell you that I sent you the application form for the next semester, which will cover pipes and power market modeling. And power market modeling is not only about actually electricity, it's all about energy and optimization process and etc. So if you understand the power market optimization process, it will be quite easy to understand other optimization process easily. So yeah, if you want to join, please send the application as soon as possible. And we are sending out the registration form, first stage of registration form for those people who already applied. We sent out we sent out about 30 registration forms already. So if you apply now, we will send you the registration form when possible. Okay. So how was the last week? I was in Bangkok to take a seminar about the trainers prepared by Agoda. It was very useful, and I found some techniques that I can use. But obviously not for this semester, unfortunately. For the next semester, I could be a little more interesting lecturer, I think. And for the next semester, we have a couple of more, 3 guest lecturers, one Nashwin from Amber, and Pilsuk Won from Jesse in South Korea, and Jung Serok from Chicago University. They will explain more about how to use, what type of energy models we have and how to change policies using energy models. Okay, really, I need to start this week 7 now. So so far we went through allocating. Basically, we went through allocating global emission, carbon budgets to each country using population and GDP and etc. That's what we are going to do. And then until the last week, from my understanding, that we imported all the files and clean up the file and then merged those data sets and then calculated global budget based on 2020 budget data and emissions between 2021 and 2023. So we are going to review what we have done so far, and then we will build up from there for today's seminar. Okay. Okay. This is cleaned version that we've been through so far. So I'm going to explain one by one to review, and then this is a good time to rerun your course, your collab, because we need the collab output in the end for this week. Okay, we are going to mount the drive. Always eDesk run anyway. Then let's wait a little. Please open your collab, Google Colab, and let's run through together. Of course, I will zoom it. Is it good enough? Okay, thank you so much. And then we are going to import pandas library as PD. And then set up the path. But for those this path doesn't work, you can actually type in the entire path from the file, from the directory. So you can go to the directory and you can find your own file. My drive, in my case, I have the files in column notebook. And then we can, for example, if we want to get this greenhouse gas emissions, we can go and copy the path, and then we can copy it here. Okay, so we can create the path, and we are going to import GDP, CO2, and population. Now we have those 3 files, and then now we are going to clean it up. we are going to use only country code and 2023 files, nothing else. I mean, technically, as Yoon Se-jong told us that we need to use accumulated data set. However, in this case, we want to make entire course a bit simpler, so we are not going to use the accumulated one, but we are going to use only the last year's emission and GDP and population as well. And then World Bank data has two dots in World Bank data, two dots represent NAN value. So we are going to change two dots to NAN. And then we will merge them. There was a very good question why we needed to do merge twice, one for GDP clean CO2, and then merge DF and pop clean. We need to run merge twice. It's because this merge method always take only two parameters. It doesn't take 3 parameters or 4 parameters, always 2 parameters. However, there's another way is here. You can do merge GDP clean and CO2 clean first using country code, and then merge. You can just without enter, you can add that merge pop clean, which means population clean, on country code as well. In this case, this takes only one parameter. You already have another parameter, which is this part, right? You can write it down in this way. However, this really doesn't help much. Later, when you have an opportunity, try to use PLAS. PLAS have a better way to do this. However, the reason that we use pandas is because pandas is some sort of standard way of doing in Python yet. So we are going to merge the data set, and then we will read global budget file. This has the global budget by temperature. And then if we run it, and then if we select only the temperature 1.5 degree, we can see the probability and the budget, remained budget in gigaton. Right? Is everyone following yet? Or if somebody finding something is difficult, please hands up. I'm going to happy to answer anytime. And then next we are going to change the unit. Okay, great. Thank you so much, always. And next, we are going to change the unit. We have a unit in gigaton carbon, which is which is GTC, right? But we need to change this GTCO2. That way, we need to multiply. To do that, we need to multiply 3.665 to the value. And then if we run it, we get budget CO2. So how it worked? So we take value from budget data frame in the budget column of budget data frame, and then multiply 3.667, and then put the value in budget DF, budget CO2 in budget data frame. So automatically this data frame will have another column called budget CO2. More explicit way to do it is going to be something like this. I will explain you the difference later today. Now we have all the data sets. Now what we need to do is import global emission data. There was a question, why do we need to do this again? Because this budget data is the total remaining budget, global remaining budget by 2019. Global remaining global budget after the January of 2020. So because we want to model from 2024, we need to subtract emissions between 2020 and 2023 from the value. Why not 2024? Because we don't have data for 2024. I mean, why don't we start from 2025? or 2026, because we don't have data for 2024, unfortunately, yet. We will have the data probably in 6 months or something like that, 6 or 7 months later, from World Bank or IEA or somewhere. So now we are going to import green global emission data, and then change its head. Only select the data, only select the columns that we need, and then put it in the data frame called historical data frame clean. There's some sort of way that I make variable name. So these first 4 letters explain what data it is, and then 2 letters after underscore explains what sort of what kind of variable it is. This is data frame for me. Sometimes it can be DT, which is dictionary, or AR, which represent array or something like that. And then if this is clean, means that data itself is all well organized. Now we can use it. So that's way that I use. And then we need to rename it. This 2020 bracket YR 2020 bracket is not the best way to use the data, because this is a very standard way that World Bank use. However, this is not the best way for Python users. So we are going to change the column names. And now we have the data set, clean data set. What we are going to do is we are going to subtract emissions now, those emissions from the remaining budget. By doing it, we have clean budget data. As you can see, sometimes it goes negative, which means we already missed 1.3 degree target. And again, same for 67%, 1.3 degree target as well. And then, yeah, 50%. So basically, we don't have limit our temperature below 1.3 degree by 2100. So that's what this one is saying. And let's jump into our week 7 lecture. We have a lot of things to go, but it's not going to be too difficult, because you at least 12 people here followed so far, and I'm pretty sure the rest is not going to be too difficult. So where did I get the remaining carbon budget data? I got this data from IPCC. You can go to IPCC report and find table summary for policymakers table SPM.2, and you can see this kind of table. And in the appendix, you can find a bit more detailed data set. And I turned this data set into CSV for you to use it. So basically, what we saw, the number that we saw so far is well aligned with other research. This is the research published, if I remember correctly, published in 2021 or something like that. Hello, August. And basically what it says is, if we don't limit our emission by 2016, if we started to reduce our emission from 2016, then we will have about 30 years to reduce our emission before it hit 1.5 degree. However, if we don't reduce our emission by 2025, or if we don't start to reduce our emission before 2025, then we are not going to have much time, maybe less than 10 years. And that's basically what the result we have so far explains. So, and then that's what the weather now forecast, the historical temperature of last year said. We already missed 1.5. It was 1.64 or something like that. Last year's temperature was 1.6. So what we need to target from now on is bring 1.6 back to 1.5. That is going to be policy target. But then the question still remains. So, okay, now I understand how much emissions remaining carbon budget that we have. but how can it get there by year? So how much we need to reduce? It is more political decisions, and it's more it is similar to trade. So one every single country wants to actually emit more rather than less because it costs. However, in this session, we are going to see how different way of allocating these emissions to each country will affect the total emission of each country. Yoon Sejong from Plan 1.5 already explained what kind of approaches that we have for fair share allocation. Sometimes English is not too easy for me. Unfortunately, it is today, I think. And the first one is based on the responsibility. So what is responsibility in terms of greenhouse gas emissions and global warming? It is basically amount of CO2 or greenhouse gas emissions that a country or a person emit. How long? During the last entire life cycle. For me, 45 years. For somebody, maybe 25 years or something like that. So the easiest way to determine the responsibility is going to be the amount of emission. Since when? 1900. So since after the Industrial Revolution. Another way is going to be capability. So one can say, okay, there is a country which has more economical capability, and then there is a country which has less economical capability. And basically, the economical capability at the moment of these years or this era has been based on greenhouse gas emissions because our entire economy is based on fossil fuels, right? So obviously, those who has higher GDP may need to pay more. Or the other way is, if GDP is too low, then we should not we should not include those countries into the carbon budget calculation. So we need to let them just freely use whatever they want. That's an idea. However, when they reach a certain level of emission, certain level of GDP, then they will need to include it in the country, in the system. So they will have some sort of remaining carbon budget as well. And another way is basically having a equal amount of emission per capita over time. And that's what equality is. And even in equality, there are even in entire this concept, there are two different approaches. One is using the historical data set. Another is using the forecasted data set from like SSP data set, socio-economic, shared socio-economic pathway, right? So based on the forecasting pathway, we can set the equality as well. And another way is we can set some sort of middle between responsibility and capability. Not just between responsibility and capability, but also we can find some sort of balance between cost effectiveness and capability need. And also we can put all of them together and then put some sort of weight. For example, one can say, okay, capability need is about twice more important than responsibility, and the equality is probably half important than responsibility or something like that. You can put some sort of mathematical weight factors to each. I mean, but this weight factor is not actually based on any science or mathematics, but this is all about political debate.